to start with, do I really need all of this text anymore? You know, we really didn't use it in the function blocks, so I'm not going to sweat bringing that over. Let's go ahead and I'm going to close out my ladders, and now I'm just going to refer back to my function blocks, and let's open our modes SCL. And I'll start by defining our modes in comments. So we've got warm-up mode, we've got stabilize mode, generation mode, cooldown mode, idle mode, and fault mode. And idle should have a mode at the end of it. Okay, warm up, stabilize, generation, cooldown, idle, and fault. I think that's it. And let's get some space in between here to write some actual code. Okay, so for warm-up mode, I remember the first thing that we're doing is we're analyzing our system start push button to transition into this mode. So let's start with if system start push button and idle mode, then start, where is it? Start sequence bit, colon equals 1, semicolon, end if, and that is going to set that bit, but remember, we only want that bit to one shot. So if we're in idle mode and someone's pushing the start button, then we're going to set that to 1, but we want to set that to 0 otherwise. So else, and we're going to say start sequence bit, colon equals 0, semicolon. So if those two things are true, we're going to set it to 1, but immediately after one scan, we're not going to be in idle mode anymore, because we're going to start our sequence and we're going to go into our warm-up mode. So the next time around, this is going to be set to 0, and henceforth, this is just going to be 0. So that's cool. Next, we need to set up our baffle PID. So if we're in warm-up mode, then, and I'm going to end this block here, and we're going to do all the fun things that we need to do right inside of this. So the first thing we need to do is we're looking for, I think it was RPM to be our baffle, and yeah, warm up RPM to be our set point. So RPM is, actually let's put a semicolon after that, because we're setting, what are we setting here? It's going to be baffle PID input, colon equals RPM, and then baffle PID set point, colon equals warm up RPM. So we've got our PID set points, good. We've got our input, good. Next we need our VFD set point. So VFD set point, colon equals warm up VFD, where is it? Warm up VFD percent, semicolon. Next we go into our time management and everything to get us out of here. So we're transitioning after the oil temp has been above set point for so long. So let's come in here and we're going to set our timer and run all of that. So the first thing we want to look for is if we're looking for oil temp to be greater than warm up oil temp, then, and here's where we're going to have our timer, and we need to remember to manage that reset correctly. So grab timer operations, and we're going to call this timer from right in here. Then we're going to time, and this is going to be true. Our preset time is going to be something that we haven't set yet. So before this timer, let's call our convert to time block in here. And we're going to convert our warm up oil temp delay set point to TI1. And let's double click that TI1. Of course the tag's not defined, that's why we're clicking on it. We're trying to define it. There we go. Define it, local temp time, good. And our time in here will be that TI1. And where did the rest of our timer parameters go? Did they just disappear on us? Okay, that's strange. Let's break out of there and let's bring our timer back again. Okay, and we'll go ahead, and that other one was named 31. So we'll just call it 31. There we go. So we've got all of our parameters here. And where were we? True. Time in is going to be TI1. And maybe we're not going to use these two parameters, but I still want to have them and have them set just in case. This Q is our trigger. We're definitely going to be using that. Timeout, I'm just going to give us some generic TI value. Define it, local temp time, done. And our bool, that's going to be what actually triggers this thing. So we will call that warm up delay trigger. And I think that should be a W, not a V, if it wasn't already. Warm up delay trigger, good. Right click, define tag, that's going to be I'm going to make that a static, because you know what I'm going to do with that? I'm going to use that to reset the timer. So, alright, we've got our timer triggering if our warm-up, if our oil is over the set point long enough. Okay, so based on that we can end if. And now what happens when we get that trigger? So if warm-up delay trigger, then, and here we're going to want to reset our timer. And where's the name of that timer? Right here. So copy that. So we're going to reset that timer, and we're going to energize our transition bit. So warm up transition colon equals 1 semicolon, else warm up transition colon equals 0 semicolon, and if. Okay, so let's look at this logic that we've got, because I think that's our warm-up mode. And what this says is, anytime someone hits the system start push button and we're in idle mode, start the sequence bit. Hit that and set it to 1. And that should instantly transition us into our warm-up mode. So the next time we come around, we're going to reset that sequence start bit. Good. Then we're going to come down here, and this stuff is only going to be evaluated when we're in warm-up mode. So what are we going to do? We're going to set our baffle PID input. We're going to set our baffle PID set point. Our VFD set point is going to be set, and we're going to wait for the oil temp to be over our warm-up oil temp. And once it is, we're going to bring in our time set point and set it into the timer. And once that timer times out, we're going to trigger our warm-up delay bit here. And only then is this logic here going to evaluate. And when we realize that we have that trigger, then we're going to reset our timer, energize our transition bit, and get out of here. If we come here and we don't have that trigger, we're just going to make sure not to be transitioning, and we're going to leave that to false. And I think that's got us. Actually, the only thing that I think might be a problem is because we're resetting this warm-up inside of an if that says we have to be in warm-up mode, I think that's going to cause us a problem because I don't think this is ever going to reset. So I'm going to Control X and cut that stuff. And I'm going to come over here and paste that below. So let's just put that right there. And we'll say if not warm-up mode, then we'll go ahead and reset that. End if, semicolon. Okay, so I think that's got us for warm-up mode. Now let's take a look at stabilize mode. So the first thing I know we want is if stabilize mode, then, and we'll have an end underscore if. And you know what, now that I think about it, you see how we've got this end, this if warm-up mode? Well, watch this. I wasn't even thinking about this, but we can put an else on that, and that's going to reset that transition right there. So I don't need this separate if statement. There, I think that's a little bit better. That's elegant. That handles warm-up mode nicely. And I will use the same logic everywhere else too. So while I've got that, I'm going to just copy that and paste it into these other ones. And actually I don't need this logic for fault mode because that one's different. But we do need it for idle mode, cooldown mode, and generation mode. There. So we've at least got something of a framework going here. That's handy. Let's get some double spacing in there between these segments. I like it. And this actually, I'm going to leave that in warm-up mode even though it's kind of technically not warm-up mode. Maybe I won't. I'll go ahead and, well, just to be consistent, yeah, let's leave it there. Come on now. Don't cause problems, Paul. All right, so stabilize mode. When we're in stabilize mode, what happens? Let's go back here and relook it. We're moving current and stabilize kilowatt set point into our baffle. All right, so actually we've already got those lines right here. Let's copy those and bring them into stabilize. So now we're looking for kilowatts, or current rather. Current is going to be our input, and stabilize kW set point is going to be our input. Okay, and then what else? We have got This is just setting up our +5 and -5 for our transition. And we're transitioning once we've got our current to within the set points. So easy. That's going to require another if statement. So if, then, and if. And we need to set up those set points here. So we're looking for stabilize KW set point, and we're going to make this a TV. So we need a temp val 1 colon equals that set point -5. Copy that, paste it down here, and we need a TV2 that can be the +5. Let's define that. Local temp in. Same for that one. And so now we've got those values. And for our transition here, we're looking for the current to be within that range. So if current is less than TV2 and current is greater than TV1, then, and now we need to bring in our convert time to set our set point, and that's going to be our stabilized delay set point, which is going out to TI3, which is local temp time. And then we're going to call our timer. And that's going to be always true when we're in here. Preset time is the TI3 we just created. Bool out is going to be, what did we call that last one? Warm-up delay trigger. Yeah, that sounds fancy. That's going to be our bool out, but instead of warm-up, it's going to be stabilize. Stabilize delay trigger without a W in front of it. Okay, right-click, define tag. And we said that was going to be a local static. And actually, the more I think about it, the more I think we don't want those to be statics. So I'm going to delete those. And I'm going to make those temps. So let's go ahead and redefine that. Local temp bool. Let's get all those stupid tags out of my way. Define tag, local temp bool. Okay, think that's smarter. So Q, and then sure enough, whenever we clicked away, we lost the ability to put in our ET. So let's put our elapsed time in here as well. And that's going to be TI, come on now, TI4. There we go. And define it. It really does not want me to define it, does it? Oh, I think I see why. There we go. And why is it not accepting this? I don't want to have to redefine this timer. What am I missing? I'm missing a comma here. Is that it? Yes, okay. So let's define that tag. Local temp time. Finally, we've got our timer set up. Okay. So if the current, then great. Otherwise, so else. And I think we need to reset the timer with an else here as well. So let's put that in up here. So else, because what we don't want to happen is this to be a kind of retentive timer, and I think that's how we're setting it up if we don't put this reset here. So I'm going to copy this timer part right here and put that in. I'm going to put it in here as well, but I'm just going to replace the timer name. Okay, so otherwise we're going to reset that timer. And then if we don't do that, we're going to come down here, and I guess we need to reset our transition bit. We haven't even set our transition bit yet, so let's go ahead and punch that logic in here, and I'm going to copy and paste that from here as well. So let's copy that, bring it down. If we get our trigger, then we're going to reset our timer also. And actually, if I'm resetting the timer in these two places, that really doesn't make sense, because I could just put that right after here as an unconditional reset. So yeah, I'm still smithing out my logic as I go, forgive me. This is going to be our stabilize transition. And you know what, I'm just going to leave those resets like that, because I think if I take them out of there, what's going to happen is I'm going to be resetting the timers all the time. So let's leave them there. I think it's going to work. I think we're good with that. So the else we need here is we're going to reset our transition and make that equal to 0 if that stuff isn't true. So stabilize transition : equals 0, not 10. And if, and I think we've got that mode done. Let's start working on our generation mode. Generation mode, I know we want to engage our interlock. So that's our station interlock control : equals 1, semicolon. And I think we also needed to manage our PID. So let's look back and see what else we were doing in generation. Nope, actually we didn't need to manage anything. We just needed to wait for our stop push button to transition out. Easy. So while we're in generation mode, it looks like we're not even going to need that else. So actually we might to reset a transition bit or something. So yeah, let's leave that there. And then if system stop push button, and we're looking to be in generation mode. Actually, we've already got that, so I'll just say if system stop push button, then, and we're going to energize our generation transition. So generation transition : equals 1, semicolon. And if we're not in generation mode, then we just want to make sure to reset that to 0. So otherwise, boom, slam us out of that bit. And I think that's all we needed for transition. That was simple. Let's go to cooldown. For cooldown, we want to reset our interlock control first and foremost. So station interlock control : equals 0, semicolon. Done. That's the most important part. And then we want to shift our PID back to looking at RPMs, and that needs to be a cooldown RPM. Okay, so Let's grab those. I think I've got a good one from the top. Those are pretty close. Let's copy that. Come down here. So our PID-N is RPM. And now we're looking for a cooldown RPM set point. So COOL, cool down RPM set point. And let's go back. And we've got a cool down oil temp that we're looking to attain and hold for a certain amount of time to engage the transition. So that's pretty easy. Let's go back into our mode. And if oil temp is less than cool down oil temp set point, you know what? This logic feels really familiar. And that's because we've been using basically the same thing right here. So I'm just going to snatch that from there, come down here and paste that in. Okay, so if we're looking for oil temp is less than cool down oil temp set point, we don't have any other conditions, so let's get rid of that. Then we need to convert time. We need our cool down delay set point. We're going to store that to TI5, which we'll define as a local time. Then we need a fresh timer here, so let's drag that guy in. Give it data. Our Boolean in is of course true. Preset time, TI5 that we just created. Boolean out, that's going to be our cooldown delay trigger, which is a local temp bool, and our timeout is going to be TI6, or not really timeout, but elapsed time, which is local temp time. Good. And otherwise we're going to reset timer. Let's paste the name in there and there. And if we get our delay trigger, then we're going to cool down transition. And otherwise, if we're not in cooldown mode, then we're going to reset that transition bit. Cooldown mode is done. Idle mode, let's see if we can remember this. We're going to first of all set our break. So break control colon equals 1 semicolon. And we're also going to look at our oil pump VFD control, which will be set equal to 0. Our baffle control will be set equal to 0. And what else? Were we also doing our interlock just to be on the safe side? I don't remember. Yeah, station interlock also. So station interlock control colon equals 0 semicolon. And we don't have any else's. We don't have anything else to worry about there. And then our fault mode is going to be if, and now we need to look for our alarms. So if eStop, why is it only giving me eStop notify? I want eStop alarm. If eStop alarm or brake failure alarm or overcurrent alarm or overspeed alarm or high oil temp alarm, or oil high flow alarm, or oil low flow alarm. Where is it? There it is. Then, and now we're going to set our fault mode. So fault mode colon equals 1 semicolon, else fault mode colon equals 0 semicolon, and if semicolon.